Good morning, students. Today we are going to start a new topic in the subject of Mathematics D3. The topic's name is Geometrical Properties of Circles. So concentrate yourself. First, I'm going to tell you two starting properties of the circles, geometrical properties of the circle. Suppose a circle is given and a chord is given. So first you have to understand the difference between the chord and the diameter. Chord is a line that touches the circle at 2 points but that does not pass through the origin. And diameter is a line that touches the circle at 2 points and passes through the origin. So here is the origin. So the line that does not pass through the origin and touches the circle at 2 points is called a chord. So a chord is there in a circle. If we draw a perpendicular from origin to the chord will be bisected. And reverse is also applied. If a line which is drawn from the origin to the chord, and if chord is bisected, the line will be perpendicular. So reverse is also applied. So listen again. If a line from origin to the chord is drawn that is perpendicular, the chord will be bisected. And if chord is bisected, the line will be from the origin to the chord will be perpendicular. Okay, the second property is equal lengths of the chords. If there are two equal lengths of the chords in a circle, so listen carefully. If there are two chords of equal lengths in a circle, then the distance from the origin to the chord will be equal. Two chords of the equal length will be equidistant from origin, and reverse is also applied. If two chords are equidistant from origin, they will be of equal length. So these are two properties, and from these two properties we are going to solve a question that will make your concepts more clear. So look carefully. The lengths of the two parallel chords of a circle of radius 12 centimeters. So this is the radius of the circle, are 14 centimeter and 8 centimeters. So these are the lengths of the chords. Calculate the distance between the chords. Okay, from here, this statement, we can see there are two cases. So because it is not given, either the chords are on the same side of the origin or on the opposite side of the origin. So look now. Here will be two cases. Here is the origin. Suppose here is one chord that is 14 centimeter, and here is the other chord that is 8 centimeter. So suppose if they are on the other side of the origin, so if we draw perpendicular to the chords will be bisected. So 7 will be here and 7 will be here, and here is 8. So if we draw the perpendicular from here to here, so 4 will be here and 4 will be here. So this is the first case which we are going to solve. So if we join O to this point, definitely this will be the radius, and the radius of the circle is given 12. Okay, and if we join this origin to this point, this will also be the radius, this will also be 12, radius of the circle, so this will also be the 12. Okay, so look carefully now. So this is a right angle triangle now, in which base 4 is given and hypotenuse 12 is given and perpendicular is the missing. So look now, we are going to name it. So O, A, and this point is B. This is O, this is C, and this point is D. Okay, in triangle OAB, Hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 12, so it will be 144. Perpendicular is missing, so OB square, and B is base, that is 4. 4 is square is 16, so 16 will be subtracted from 144, that is equal to OB square. So 144 minus 16 is 128, and taking square root of both sides will give us the value of OB. So square root is 11.31. Unit used in the question is centimeter. Okay, this distance is done now. Now we are moving to triangle OCD. So in triangle OCD now. So hypotenuse square, again this is a right angle triangle, so Pythagoras theorem will be applied. So hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 12, so it is 144. Perpendicular is missing, that is OD. So OD square is still there, plus base is 7, that is 49. So OD square will be equal to 144 minus 49. So 144 minus 49, that is 95. Taking square root of both sides, so 95 square root is 9.75. So because the distance between the chords will be equal to, so required distance will be equal to OD plus OB. OD is 9.75 and OB is 11.31. So adding them, is 21.06. So this is the one case in which chords are given on the opposite side, because in the question it was not given. So we have to solve the two cases. So now the second case, look now. Here is a circle. Here are two chords which are parallel to each other. Here is the origin. So now the chords are on the same side. So definitely the chord which is having greater measure will be this one, and smaller measure will be this one. So we are going to draw the perpendicular. So this will be 7, 7, and this will be 4, 4. So again we are going to draw the, we are going to join origin with this point and origin with this point. So again Pythagoras theorem will be applied. So look now, this will be radius and this will be radius as well, that is 12 and 12. So this is 12 and this is also 12. So we are going to name them O, A, B, this is C and D. So in triangle OAB, so hypotenuse square, Pythagoras theorem is going to be applied. Hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 12, that will be 144. Perpendicular is missing, that is OA square, plus base is given, that is 7, so 49. So 49 will be subtracted from 144. So will give us the length, this one 9.75. So OA will be 9.79. So look now, this will be the same case, but at the end there will be a difference. So now in triangle we are going to join this origin with this point. So now in OCD, hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is definitely the radius, that is 12. So here is the 12. So that is 144. Perpendicular is missing, that is OC square plus base is 4. So 16. So look now, this will be this case. So 144 minus 16. So OC will be equal to 11.31. But at the end, there is difference now. We are required to find the distance between the chords. So AC is the requirement. So AC is equal to OC minus OA. Now putting values into it, OC is 11.31 and OA is 9.79. So subtracting them, 11.31 minus 9.79. 1.52. Unit used in the question is centimeters. So answer is 1.52 centimeters. Now we are going to read three more properties of the geometrical properties of the circle. The next is the angle made by an arc at the origin is double the angle that is made at the circumference of the circle. So look again carefully. The angle made by an arc at the origin is doubled this angle made at the circumference of the circle. The next property is the angle made by the diameter of the circle. Diameter is a line that passes through the origin and touches the circle at 2 points. So the angle made by the diameter of the circle at the circumference is 90 degree. This is the second property. Okay, the third property is the angle in the same segment. So the angle in the same segment is equal. So look now, this is the segment. The segment in the same, the angles in the same segment are of equal measures. Or in other words, the angle made by an arc at the circumference are of equal measures. So these are three properties which you have to understand and learn first before doing the questions of this type. So look now, here are two questions. The statement is given that O is the center of the circle. Find the angles marked X and Y in each case. So look now, this is an arc which is making angle X, angle Y at the circumference and at the same time 25 degree. So this is the arc which is making angles. So the property is the angle made by an arc at the circumference are of equal measures. So that's why Y will be equal to 25 degree. Okay, the next thing is the angle made by an arc at the center is of double measure as compared to made at the circumference. So this is the arc which is making an angle 25 here. So the angle at the center will be double of the measure at the circumference. So it will be 50 degree. So this is the first question. In second part, if you look, this is the arc AB which is making Y angle at the circumference and x angle at the origin. At the same time, you can see this is a triangle AOB. So OA and OB are radius. So this is isosceles triangle. So if this is 35, so this angle will also be 35 because of the isosceles triangle. Their sides are equal and their base angles are equal. So if this is 35, this is 35, so it will be 70. So angle at this x will be equal to 110 degree, because the sum of the angles of the triangle are 180 degree. Okay, now AB is the arc which is making angle y at the circumference and angle x at the origin. So if at the origin angle is 110, so at the circumference will be half of it. So y will be equal to 55 degree. Here is another question. In the figure, O is the center of the circle. So here is O. Center of the circle AOB is parallel to DC. Okay, AOB is parallel to DC and AOD is 58 degree. AOD is 58 degree. Find the angles marked X, Y, and Z. So X, Y, and Z are required. So look now. This is the segment. So AD segment is making an angle of 58 degree at origin, and this is the same segment which is making an angle of x at the circumference. So x will be half of 58. So look now, x is equal to 58 by 2. So this is 29. So if x is 29, so these are two parallel lines and this is a transversal line. So this is 29. So this will be also 29. Okay. And this is a diameter which is making angle C at the circumference. So this will be 90 degree angle. So this is 90. This is 29. So 90 plus 29 will be 119. So when we will subtract 119 from 180 degree, so y angle will be obtained. So look now, 180 minus 90, this angle, and this angle 29. So y is done. So x and y are done now. Okay, now look into triangle OAD. OA and OD are radius. So this is 58. So first we will subtract 58 from 180. So look now, 180 minus 58. So this is the angle which is obtained. So ultimately, these base angles will be equal. So now divided by 2, 61. So it means this will be 61 and this angle will be 61. So if this total angle is 61 and this part is given, that is x, that is 29. So 61 minus 29 will be equal to 32. That will be equal to Z. Okay, here is another question. In the figure, O is the center of the circle and ABN is a straight line. Okay, find the obtuse angle AOC. So AOC angle is required, that is marked by X. Okay, look now, if this is 64, so this is a straight line. So we will subtract 64 from 180. That will give us B angle. So look now, B plus 64 will be equal to 180 and B will be equal to 180 minus 64, that is 116. So if this is B and this is 2B, so 2B will be equal to 2 times of 116, that will make 232. and you know the angle at a point is 360-degree total. So if we subtract 2b from 360, we will get x. So look now, 2b is this one. So 360 minus 2b. So 2b's answer is 232. So 360 minus 232 is 128. So this is the answer. Here is another question. In the following diagram, AB is the diameter of APQ and RBQ. So look now, AB, this is the diameter, and APQ and RBQ. APQ and RBQ are the straight lines. Find BPR. So BPR, this is the angle that is required. Okay, look now. This is the diameter AB that will make 90-degree angle at the circumference. So if this is 90, so the angle of the straight line is 180-degree. So if this is 90, P will also be 90. So look now, P is equal to 180 minus 90 will be equal to 90-degree. Okay, now look at the segment PB. So this is the segment which is making an angle of 45-degree at the circumference at A point. So this is the same segment which is making an angle R at the circumference at R point. So R will be equal to 45. So look now, angles in the same segment. Okay. Furthermore, if you come into triangle PQR, so concentrate at this triangle PQR. So this angle BPR plus P plus 25 plus R. So these are actually the sum of the triangles. So look now, BPR, that is BPR, this is small angle, plus P. So this is the total angle at P, plus 25 plus R will make 180-degree total. So putting values at in this equation, so P and R's value are here. So putting values here and solve it will give you the answer. Further look, this is a circle and here is a quadrilateral whose all vertices are on the circumference of the circle. So look at P, Q, R and S. The vertices of a quadrilateral are given on the circumference of the circle. This type of the quadrilateral is called cyclic quadrilateral, and the property is the sum of the opposite angles will make total 180-degree. The sum of the opposite angles of a cyclic quadrilateral is 180-degree. Likewise, this angle and this angle will make in total 180-degree. Here is a question. In the figure, PQRS are the points on the circumference of the circle. So look now, PQRS. So P, Q, R and S are the points on the circumference of the circle. It means this is a cyclic quadrilateral. So sum of the opposite angles will be 180-degree. So look now, further, PST and QRT are straight lines. PQR is 74. So PQR is 74 and QRS is 102. So QRS is 102. Find QPS. So QPS. So this is the angle required. So look now, the sum of the opposite angles will be 180-degree because of the cyclic quadrilateral. So if we subtract 102 from 180, we will get this angle that will be 78-degree. So look now, this is the first part done. Second part is RTS. So RTS. So this is the angle required. So if you see in the triangle PTQ, so this is the bigger triangle. This angle is given, this angle is given, and this is the requirement. So if we subtract these two angles, 78 and 74 from 180-degree, you will get the required answer. So 180 minus 74 minus 78 will 28. Okay, the last thing that is required is RST. So here is R, here is S, and here is T. So this angle is required. So this 102 is given. So if we subtract this 102 from 180, we will get this angle. That will be 78. This is already done. So come in the smaller triangle RTS. So this angle is 78. This is already done. That is T. That is 28. So 78 plus 28. So the sum will be subtracted from 180. You will get this answer. So this is the answer. In the figure, PAQ and XAY, PAQ, so PAQ and XAY, X and AY are straight lines. BAX 58, okay, PBX 26, PBX, so PB and X is here 26 and ABY 23. ABY is 23. Okay, find AQB. This is the first thing that is required, AQB. So AQB. So this is the angle that is required. So look now, here is 58. This is a straight line. So we will subtract 58 from 180 degree. You will get this angle. So then you will come into this triangle ABY. This angle and this angle is given. So you will subtract these two angles from 180 degree. You will get this angle. Okay, up to here, done. Now look at the segment AB. This segment is making an angle at the circumference at Y point, and this is the same segment which is making an angle at Q point at the circumference. So this angle will be equal to this angle. So one thing, AQB is done. And now the second thing that is required, that is AYQ. So AYQ. So this total angle is required now. So look now, this segment PX, this is making an angle of 26 degree here. So this will be 26 also. And according to vertically opposite angles, this 26 degree will be equal to this 26 degree. Okay, now look, this segment YQ, that is making an angle of 26 here. So this angle will also be 26, because the angle made by the same segment at the circumference is are equal angles. So look now, from here we are starting PX making an angle of 26 here. So it will be 26 also. Vertically opposite angles, this will be 26. So now segment YQ is making an angle of 26 here. It will be 26 also. So this plus this will be the angle. So look at ABQY. This is cyclic quadrilateral. So this angle plus this angle should be equal to 180 degrees. So you will subtract 23 and 26 from 180 to get the answer, that is AYQ. So that is done. So now here are some properties of the tangents. So look now, tangent drawn to a circle from an external point are equal. So if from the external point, if we draw the tangent to the circle, these will be of equal measures. This is one property. Number two, the tangents subtend equal angles at the center. So this angle will be equal to this angle. So if this is theta, this will be theta. The next property is the line joining the external point to the center of the circle bisect the angle between the tangents. So this is the center. If we draw a line from center to the external point, so the angle between the tangents will be bisected. So if this is alpha, this will also be alpha. So these are the three properties of the tangents. Now we will use them into the questions. So look now, here is a question. The statement is, in the figure PX and PY are tangents to the circle. So these are the tangents. center O, given that PX is 6.8 and OX is 4.3. Calculate OPX. So look now, OPX is the requirement. This is, for example, this is angle theta. So if you look at this triangle OXP, this is perpendicular, this is base, and this is hypotenuse. So you will put perpendicular over base is equal to tan theta. From here theta will be obtained. So this thing is done. Next is OP. Here is OP. Again, look into the same triangle, that is OXP. So perpendicular and base are given, hypotenuse is missing. So now you will apply Pythagoras theorem into this triangle. So hypotenuse square is equal to perpendicular square plus base square. So from there you will find the value of the OP. So this is also done. C part, the area of the quadrilateral PXOY. So here is PXOY. So these are actually two similar triangles, same triangles. So PXO is equal to PYO. So if we obtain the area of one triangle, we will multiply it with 2 to get the total required area. So in this triangle, again look, perpendicular and base are given of a right angle triangle. So 1 by 2 into base into height. So 1 by 2 into 6.8 into 4.3 will give the area of the triangle OPX. So multiply this area with 2 to get the total area PXOY. So this thing is also done. Okay, look now, here is another question. In the figure, AB is tangent to the circle with center O. So AB is tangent with center O. Given that AB is equal to 8, so AB is 8 and BC 5. Okay, and OA is X. So here is X. So if O is X, so OC will also be X, because both of these two measurements are radius of the circle. Find the value of X. Okay, now in triangle OAB, because tangent makes an angle of 90 degree with the radius, so this will be 90 degree angle. So this is our right angle triangle now. So we can apply Pythagoras theorem here. So this is the hypotenuse and this is perpendicular, this is base. So apply the Pythagoras theorem, equation will be obtained in terms of X. From there X will be done. So do it now. Next is AOB. So AOB. So when X will be done, so look now, if this is perpendicular and this is base, so apply 8 over X is equal to tan O. From there you will get the value of AOB angle. So this is also done. The next thing is the area bounded by AB, BC and AC. So AB, BC and AC. So this shaded part is actually required. So first we will find the area of the triangle, that is ABO, because perpendicular and base is given. So 1 by 2 into perpendicular into base will give us the total area of the triangle, that is OAB. Then we will find the area of the unshaded portion, that is a sector, that will be equal to theta over 360 into pi r square. So theta is already done. So theta over 360 into pi r square. R is X. X is also done. So find the area of the sector. Then subtract this area of the sector from the area of the triangle, will give you the answer of the shaded portion. So do it now. Here is another question. So concentrate yourself in the figure O. So this is actually the figure and the requirement is SQT. So this is tangent. Look at the triangle PQT first, because this is the external point from where tangents are drawn. So it means these will be of equal measures. So if two sides of a triangle are equal, so that is isosceles triangle, so their base angles are equal now. So we will subtract 64 from 180 and divide the answer by 2 to get this number and this number, because two angles will be equal. So 180 minus 64 will be equal to whatever, then divided by 2 will give us this answer and this answer. Okay, look at now PQ, that is a tangent, and here is the diameter. So tangent makes an angle of 90 degree with the radius. So this angle will be 90 degree total, and this angle is already obtained in the triangle PQT. So if we subtract this angle from 90 degree, we will get this angle. So that is the requirement SQT. So do it now.